Hello, everyone. Welcome back to Advent of Code 2022. Here in still, I think, March of 2023, where I teach myself Kotlin. And no matter how hard the task is, it always takes me exactly 2 hours for some reason to solve one of these things. I had a couple of improvements on the last thingy jiggy, the last day's work. So first, I was like, how the heck are you supposed to get I wrote this kind of crazy thing to get a list of the same thing n times, and I was sure I had found a better way, but I couldn't remember it, and I went and looked it up, and it's pretty easy to find. You're supposed to say, is it easy to find though? I kind of hate this because so much of Kotlin is designed for an IDE to offer you tab completion when you type foo dot and you're like, what can I do with foo? Here, to make a list out of some int, I have an int, I want to make n copies of this thing. I want to type n dot something, n dot repeat, or whatever, right? But instead, I'm supposed to know that actually I should use the list constructor, not list of, which is the thing you use all the time, but the list constructor, and pass it an int and a lambda. And then it calls that lambda on all the numbers from 0 to n. So this is how you're supposed to make a list of the same thing multiple times. So that was the first change I made. I did that in a couple places. And the other one... Oops, don't close that yet. Because I did this throughout multiple files. There was one place I left it alone. But I looked at this and I was like, I'm introducing this variable named match, which is kind of a meaningless, useless name. Why exactly do I have it? Wouldn't it be nice if I could write something that leaves that nameless? And I said, instead of calling match entire and throwing an exception if there's something there. Well, actually, wasn't there another example that was... This is version 1 of my regex's idea. And then this was kind of version 2, I think, where I said match entire question mark let, lambda taking match, destructure it as a val, and then if there wasn't anything, return a default value. But you don't need match if you say, match entire line, and then if that exists, destructure it. And then if that exists, let the result of destructuring as a destructured, a lambda that already just destructures. So we don't need to declare match, and we get a nice one expression lambda, which is nice. So I made that change in a couple places. There was one place where, because what I was letting was a pretty long... It was in the range stuff in, I don't know what day that was, 7 or something? Or earlier? I don't know. That I didn't make this change because it made it actually less readable by making it too hard to fit stuff. Anyway, doesn't matter. So those are the only changes that I made. And let's move on to day 10. Cathode ray tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. It's a good thing I have a communicator, huh? They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. By the way, why are they see you later? They're not helping? Rude? Unless, that is, you can design a replacement for the device's video system. It seems to be some sort of cathode ray tube system and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. It has a single register X, which starts with the value 1. It supports only 2 instructions. Add X, V. It takes 2 cycles to complete. After 2 cycles, it's increased by V, which can be negative. I'm very suspicious about this 2 cycles thing. We're going to have stuff like add x, x, and like, oh, we got to use the old value or whatever. Anyway. CPU uses these instructions in a program to somehow tell the screen what to draw. Consider the following small program. No op, add x3, add x minus 5. So at the start of cycle 1, it does no op, nothing happens. Start of cycle 2, it says add 3. During the third cycle, nothing's happened. After the third cycle, it's 4. So at the start of cycle 4, it's 4. It adds minus 5. Okay, we get to minus 1. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength, which is the cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. 20, 60, 100, and so on. Okay. That's a long program, but I guess it has to be since they have to consider multiple different cycles. We're supposed to add those together for the first 200, or well, for the 20th, 60th, and so on. Okay. So it shouldn't be too hard to parse this or to model the computer or to step through all of the actions. You know, getting the 20th, 60th, whatever. I mean, cycles is also, I think, not that hard. Right? So let's get our puzzle input. Cool. So once again, I only once remembered to do the pre-work of making files for this stuff. So day10.text. There we go. There's 143, so who knows how many ads are here, but presumably at least about 80. And if I make a new package here, day10, and a new file, day10, sure. Then let's just start defining things that make sense, and soon we'll have a program that makes sense, right? So we need a sealed class instruction, right, which is what we're going to parse. Or is this an interface? Why not an interface? Because it's probably going to want some method like operate on computer that returns the next state, or a sequence of next states, even better probably. You know, let's define a data class. I guess this is our communicator. What exactly is this? We're computing the signal strength for a program. It's the video system. The signal. The CPU is sending a signal, I guess. I don't know. I don't know what to call this. This like strongly hints at this being like step one of something that's going to be reused throughout the year, where we're going to be like building an interpreter for this thing or something, as some previous year did. So I don't want to just call this the computer, but I guess for now we will. So a computer has a val register could just call it val x, right? Val x is an int, and val... That's kind of it. Like, we could have it, like, keep track of a program, which is what it's executing, but so far, all we're doing with our program is, like, stepping through it one at a time. So maybe we shouldn't get too excited about modeling all this stuff yet. Let's define a data class. I don't know. Can you define an empty enum class? No, that's not what you want. You want... Oh, you know what? If I look at the... I had a previous day where I used this sealed stuff, right? Transcript entries, right? And I used class ls. It has no state and no overridden equals. Okay, what should I do about that? Yes, this is exactly what I was thinking. I was like, wait a minute. I shouldn't have a class that... I should use an object. Yes. I forgot Kotlin. I mean, okay, so Java also has, like, you can create anonymous objects, right? That are instances of some class, but they're not, like, constants. And now, suddenly, is this okay? Does this work? This is broken. Require it. Oh, and I guess there. Right? So if you have a thing that is supposed to be an instance of a participant in a sealed class hierarchy, in an algebraic data type, right? You have sums and products. I mean, we could teach some remedial Haskell here. Like, why not, right? If I were writing this in Haskell, I wouldn't have written this. I would have said data transcript entry is either an ls or a dir listing or a cd of string or a file listing of int and string, right? This is how Haskell would write these 5 lines. And this is, we call this an algebraic data type because it's composed of sums and products. This type is the sum of an ls or a dir listing or a cd of a string or a file listing of a product of an int and a string. Why they're called sums and products, I don't know. We don't have to get into right now, but the point is, if you have a choice among things, that's a sum. And if you have a combination of things, that's a product. So classes in object-oriented languages are, generally speaking, products. Interfaces or inheritance in general is how you represent sums. So this is how I would define... This is my Kotlin version of what I wanted to write, which was this. Longer, but not unreasonable. And I said, oh, okay, you have an interface, which is like transcript entry. The interface represents the type, which is like all of them. And then you have a bunch of classes, which implement the various options in the sum. But a class with no stuff in it should really just be an object, according to Kotlin. This isn't really an option you have in Java. Like, yes, obviously you can define an anonymous object that implements transcript entry. But it's just weird and hard to deal with because objects are different from classes and you can't really test for membership. Like, you can't test, is this an ls? Because an ls like never really existed if you do it that way. But in Kotlin you can. You can say, I have an object and it's a transcript entry. And then you can ask, is this transcript entry an ls? Or you can say return ls or whatever. And I assume you could also say is. Yeah. you can say, is this transcript entry in ls? And it's like, yeah, it's that one. So, great. This is what I just realized as I was starting to write this. I was like, wait a minute, why am I going to use a class? Shouldn't I just use an object? And I went back to the other one, and indeed, the IDE was telling me, why don't you just use an object? So, object. I mean, it's a little weird to give an object a capitalized name, isn't it? I don't know. We'll just say for now, object no op is an instruction. And it will probably, we'll add some methods, at least one to instruction, and no op will implement those methods, and that'll be fine. And then we also need a data class addx amount, delta, sum and delta, sure, is an int, which is an instruction. So these are my two instructions and my little my very, very humble algebraic data type. And we're going to parse into this. So let's start with that. Fun parse takes a line, which is a string, and returns an instruction. Let's say val no op regex. I don't know. That's kind of if you do this is kind of like bad Hungarian notation where like you can already tell it's a regex from the type. Why are you putting that in the name? Usually I don't like to do that, but I was like, oh, I was a little worried about you know, confusion with this other no-op thing, but I'll just assume that this will be clear enough. It's a regex of... Well, I don't really need that, do I? Yeah, maybe let's just not even do that. Val add x, though we probably do want a regex for. It's a regex of add x and some digits. Optionally a minus. And then some digits. Seems okay. So can we just say when line is no op? Like that? And otherwise, it's add x dot match entire of line. No, not destruct. Well, yeah, I guess. Question let, right? I can just get out the first one. Well, I don't know. Destructured seems okay. Same way I was doing it before. And this is going to be delta to add x of delta.toInt. Doesn't that work? Oh, hang on. Gotta destructure it like that. toInt. So and this returns the wrong thing, right? Yeah. So or else throw runtime exception, no parse for line. Right? And we can even take this and make it a... That's not so bad. It is kind of bad, actually. How about that? That's not bad. Sure. So I want to make sure that this actually works with negatives. I assume if you take -1, the string, and call toInt on it, I assume that works, but I'm not actually sure. Let's also make sure... Nope, that's day 9. Let me close some of this other clutter here. Yeah, I have correctly understood the input file, I think. Has my program correctly understood it? What if I parse... no op. What? Parse? No op. This is some object, but it's an instance of no op. Great. And if I say add x minus 51, it's an add x with a delta of minus 51. Perfect, as we hoped. So there's our parser. So I think this is where we should start saying, what is the interface of an instruction that we want both of these things to be able to do? And I want, I think, for... Wait a minute, should this be part of an instruction? Maybe not. Maybe we'll just pattern match on them instead of giving them some behavior themselves. Like, let's just write a main and see what happens. Fun main. Val program equals read input of 10 dot map parse it. Right? Seems good. It returns an int. Well, sure. Obviously it has to return an int, but I was wondering if I, instead of like just going straight to part 1, maybe I should write a function that simulates the computer some number of times, right? Like, and have that be what main does, and then, oops. And then call part 1 on the set of computer states. But for all I know, part 2 is going to change how you interpret the program and what the computer does. So I'm going to have part 1 do everything we need to do for part 1. I don't know what belongs in part 2 yet, except for like parsing and this type. So let's say var, the register starts at 0, I assume? It starts at 1. Var x. For a change, even no matter what the scope is, x is the right name because that's how it's defined in the spec. Var x is 1. And I think we want a sequence of states that the computer has gone through, right? So let me just double check what the timings are supposed to be. After 2 cycles, so like cycle 1 is the first cycle, not 0, sadly. And at the start of cycle 2. During cycle 2, it's still 1. During cycle 3, it's still 1. In between cycles 3 and 4, it's turned into 4. Okay. So I mean, I think I want the program as a sequence for some reason. I don't know exactly why. I think I want to flat map over it. You know? Yeah, that's the stuff. I want to flat map over it, and then I want to scan over the resulting sequence, right? Where what I get is, when I flat map, I want a list or a sequence of what changes should happen to X at the end of this cycle, I guess. How much X should change by, right? So let's say instruction to when instruction, fill in the cases for me. Why are you not, what's wrong with you? I understand I haven't written it yet, but add remaining branches. There we go. God, I hate this orange highlighting just because I haven't told you what type this is supposed to be yet. Okay, val tick changes, which is a sequence of int, is this. Now you can infer it. It just isn't done. Candidate was chosen only by. Ugh. So, no, not empty sequence. That's wrong. I want this to be a sequence of 0. So, yeah, see, now I don't even have to specify this, do I? I don't know. I feel like IntelliJ is usually pretty good about giving you some leeway for when you're not finished writing your program. It's sure, it tells you oh, this isn't finished, but doesn't get all up in your face. I hate that fucking orange though. Okay, so when you're supposed to do nothing, we say sure, that'll take 1 tick, and then do nothing. And when it's an add x, it's a sequence of 0 and instruction dot delta, right? So first tick, nothing happens. Second tick, something does happen after it. And so we have a sequence of how much x should change by. And I think I actually don't need this x at all, because I'm just going to scan over it, right? And I can say val states, or are they? I mean, they're called signal strengths or something. But is that only something that's true when they're at the signal strength? Yeah. So signal strength always describes these cycle number multiplied by the value of x. Okay. So first we'll compute the x's, and then we'll zip that with the cycle number to get signal strength. Sure. And then we'll take only the 20th and every 40th after that. Right. X's? X's, I guess, is tick changes dot scan. Oh, look, scan indexed. Well, I could do that. So I also have to think about off by one errors when I'm like scanning here. So suppose my very first instruction were to like add 5. That should not appear in the first cycle, not appear in the second, but it should appear in the cycle labeled 3, which if we're zipping indexed at some point would be the 4th one. So I do actually want like the 1 that gets added to the front of the scan, I think. Scan of 1 lambda. And we'll say x2. This is really easy, isn't it? It's just x plus... Oh, wait, sorry. It's x and delta, right? So shouldn't I just this whole time say like int plus, like, right? So what if I just did this and I debugged this program? Does it like scan things properly? Does the list come out the way I wanted? Our very first instruction is to do nothing a couple times. A return expression is required. Okay, fine, you got me. What? Where did it stop? It's here, huh? For some reason I guess... Did I stop here? No, it says running, right? That's a little worrying. No, I can't pause it. I could resume it. So it's not... Okay, the thread is runnable, but... Anyway, I don't know. I just realized... I'm so used to, from the way IntelliJ was configured at my last job, that when it's suspended, the line should be highlighted in like this dark yellow. Pale yellow, maybe? I don't know. Anyway, apparently no. Stock is to highlight it in blue. But that's the same. It's just like, it's so close to the line, right? Like these are so close. I should change this to be horrible, ugly yellow. So, what did I get in X's? It's a sequence which I assume has not been realized yet. But I thought there was usually like a button on sequences I can hit to be like, yeah, look it up, baby. Tell me what it actually is. No? I mean, I guess I could just evaluate this. Sequence, or no, they're called X's dot take 10 dot to list, right? That would do it. So it's 1, so in cycle 0, which is the first, which we're saying is cycle 1. Okay, let's look at our program here. Cycle 1, it should be 0. Cycle 2, it should still, sorry, it should be 1. It should still be 1. At the start of cycle 3, it's still 1. Then at the start of cycle 4, it's still 1. And at the start of cycle 5, which is this one, but labeled 4 because we're doing 0 indexed, right? So if we say this is the first sequence, the first cycle, because it is, This is second, third, fourth, fifth. In the fifth cycle, it becomes 6. It should be 1 here, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5. So 1, 2, 3, 4. So this looks right, sort of. I'm still a little nervous about the 1 indexing. Right? So if I were to look, I guess, at like the first 20 of these. Then this is cycle 1. This is cycle... Am I stupid? Why am I starting at 1? Why did I want 20 of them? I'm clearly not counting all the way to the end. I don't know. Cycle 1? It should be 1, and it is. Well, if I'm calling this cycle 1, then it should be 1. If I'm calling this cycle 2, it should be 1. If I'm calling this cycle 3, it should still be 1. Cycle 4, it should still be 1. So, okay, I just have to know that, like... Well, there's a few things I could do. One is, I could just add an extra 0 on the front of the sequence, and then say cycle 1. Cycle 0 is like you're not supposed to look at it. Cycle 1 is what cycle 1 is in the thing. Or I could like offset everything by 1 while reading it. I think I'm just going to add an extra garbage 0 to the front. Or 1, I guess. Is there a good way to... Like, is there a cons? Or am I supposed to create a sequence? Like... I assume there's not something called cons, but there might be something like it. None of this is looking promising. What's on each? Ah, that's the way you can, maybe. The way you can chunk things with the sliding window, maybe? I'm not sure. Maybe not. Single? Is single supposed to be a way you can claim the sequence only has 1 item? I guess so, yeah. Okay. Ah, it's called windowed. Look at that. That was something I wanted, or I thought I might have wanted earlier, but ended up not wanting. I think. Or maybe I just did without. Okay, so fine. We can say it's a sequence yielding 0, and then yield all of this. So this is just a really convoluted way to say cons, but okay, I guess that's where we are. What is this? I don't know what this means. Okay, so now we have like a sequence of all of the things starting with 0, 1, and so on. And we could like look up what's number 20, what's number 60, and so on. But I think what we should do is just like return return x's dot map indexed. Actually, wait, do we have like filter indexed? X's dot. Of course we do. Kotlin just has every dimension you could want something on, multiply together all those dimensions, and then just give every single one of those things a function on every object. But okay, this time I want it. So, I mean, great. So I think I just want filter indexed of index x, basically, right? To index mod. I assume this is still % mod. Index mod 40 is 20. Dot. No, I'm right. I'm supposed to map index first to get the signal strength. Yes. So map indexed. Wait, why are you not? Map indexed. Oh, like this. I want a lambda, yeah. Index x to x times index, I think. Oh, we'll change index's name to cycle number. Likewise here. Actually, wait, are these even the right order? An int and then a t. Yes, okay. Cycle dot sum. Right? That looks okay. So we're ignoring cycle 0, and then we're looking at all the others. Computing the cycle num for each of them. I guess really we should filter. No, if we filtered first, this would get the wrong indices. Okay, let's just like run this. What button did I guess I must have accidentally clicked run. That's nice. It's a number. We always like to see numbers when that's what the problem asks for. Well, I guess I'm just assuming there's only 200. How many instructions do we have? I should be a little careful there. Yeah, it's not actually asking for every... What exactly is it asking for? Every 40 after that. Okay, so... So, I mean, it's saying the 20th and every 40th after that, which is to say these, right? So I think these are supposed to be considered equivalent. So let's just paste my number. It's the right answer. Fantastic. Great. So, anything I want to change before I get this bad boy committed? I don't think so. Let's not include the day 7 change here yet. Or actually, let's do the day 7 change first. Day 7, use object instead of empty class. Day 10, part 1. Let's see what part 2 is all about. Seems like X controls the horizontal position of a sprite. The sprite is 3 pixels wide, and it sets the horizontal position of the middle of the sprite. There is no vertical position. Horizontal position puts its pixels where the CRT is drawing. Okay. 40 wide by 6 high. So it's going to be some letters, of course. Draws the top row left to right, then the row below that, and so on. It draws a single pixel each cycle. Okay. 40 wide by 6 high. Okay, so that's why we can fit. Okay. Carefully timing the CPU instructions and CRT drawing operations. Uh-huh. So we were basically looking at the middle column, I think, right? Sort of? No, probably not. We were looking at what value X has when the CRT was drawing these pixels. Okay. Sets the horizontal position. The X register sets the horizontal position of the middle of the sprite. Carefully timing the sprite position such that one of its 3 pixels is the one being drawn. We get a hash, otherwise we get a dot. So if the sprite is there or adjacent to it, okay. Okay. Yeah, 8 capital letters, sure. So we already have, or can get, a sequence of at every cycle what the value of X is at that cycle, right? So we don't care about signal strengths anymore. That was just to show that we had correctly reconstructed the sequence. So if we have an X and a cycle, then it would be kind of nice, right, to turn this thing into, we have like a long stream that goes on like this, into just a sequence of bools, right? Whether the pixel is on at that cycle. And then we can take the sequence of bools, split it into chunks of 40, and turn each of those into a line, right? I think that's the approach that I want to take. It requires a little refactoring. Because this part, I kind of want to be its own function, right? We have kind of funny. We don't want the 0 in this case, huh? Okay, but I want like most of this to be its own function. What is that? Control Alt F maybe? It's still M for method. Very funny. Okay. Sequence 1? Yeah, sure. So we'll call this X values, the values that X has. I mean, I guess we want a little bit more than this, right? Because we do actually sort of want the correct cycle number labeled here, not just it's the 0th element of the sequence. So let's undo extracting this for the moment and fix this part up so that we don't insert a dummy value, but instead just like label things differently. Just make it this. And map index to a pair of X and cycle num. Except it's actually cycle num plus 1, because no, shoot. Right? Yeah, the 0th one is what it is in cycle 1. So yeah, cycle plus 1. And then we just want a normal filter here. Except we're going to like extract all this to a function, but we'll do that after this part is working. Just a normal filter, because we already have the indices. Actually, it's kind of nice if it's... Feels like the cycle num should really be before X in the pair, doesn't it? Yeah, arrow X, that's right. Dot sum. So, the first thing is, have I broken things yet? Because this was supposed to be... Sure. This was supposed to be a semantics transforming thingy. And this is way wrong. Oh. Of course. Cycle num. We didn't ever actually multiply. $12,980. That sounds familiar. Let's just double check. Oh my gosh, I'm lost. 12,980. That is correct. Okay, we haven't broken things. So, now I want to take this part and make it into a function. Is that allowed? No. I want to take, like... Right? It seems like that should be allowed. I get that it doesn't want to because there's this return in the middle of things. But I want... I don't know. I can do it by hand. Make that a function. Call it values labeled with cycle. No. Okay, good. And then just take this map indexed and put it in there as well, right? And it doesn't, yeah, update the return type, please. And really, I think this pair of int and int is easy enough to get confused that we should give it a name, right? Data class register info has a val cycle num, which is an int, and a val x, which is an int as well. And really, this should return a sequence of register info. There. Now this is labeled, which feels a lot more comfortable. And is part 1 still right? It is, but only because cycle num is the first argument in our data class, right? It's destructuring them rather unpleasantly. Let's say info red, I don't know, with reg. Right, so now at least we don't rely on the ordering of things. This is kind of an interesting contrast to the way I was saying that with kind of hides where variables are coming from. And it totally does. I regard that as a downside of what I've done here. But now we don't have to worry about destructuring or whatever, or getting the stuff in the wrong order because of how we look it up by component or by destructuring. We just bring the fields into scope by name, and you can't really possibly use the wrong name, right? So I think it's actually not that bad here. Right? I don't know. Looks good to me. So is this all still right? Yes. Let's just commit this. No, because this is all intricately tied up with part 2. It's not some special like refactoring that was great for part 1. Like it was okay, but we didn't know what we were going to need in part 2. I think it's reasonable to call this part of the part 2 solution. And let's move part 1 down here. And copy it to be part 2 as well. Oh, except actually it's a string. New line. String. Okay, cool. So I just want to make one big string with new lines in it that's got hashes and dots, right? So now I have the values labeled with cycle nums. Maybe I can rename this because I gave it register info. Sure. Register info by cycle. I don't know what I'm returning yet, man. So I'm not looking at this let me just super double check. I don't care about signal strength anymore. The X register sets the horizontal position. Leftmost is in position 0. In cycle 1, it draws position 0. God, I hate you. Why couldn't it just be cycle 0, man? Okay. Now, first question, do I want to break this list into chunks of size 40 before or after I compute what's on? I guess since I have the cycle info and that's what I'm going to be using anyway, it kind of makes sense to just leave it as one big blob, I guess. Okay. So let's just write some stuff. X's is not a great name, I guess. I want to map this with a lambda. Register 2 with reg. No, you know what? I want to map index. No, I don't. I already have the index. It's in the register info. Let's say val column. God, except okay. Yeah, column being drawn is cycle num -1 mod 40, right? And cycle num is always positive, so this will not have any issues. Right? In cycle 1, it should be drawing column 0. Yes. Okay. And don't we just want to say we have X, which is the sprite's horizontal position. We just want to return X, the ab X, X minus column being drawn dot abs. I thought, how do I import? I know it's absolute value, but it was called abs a minute ago, wasn't it? Am I crazy? Wasn't it just like in day 9? It's called abs. Why are you giving me this shit? Ah, because these are free functions. Okay, I see. I don't want absolute value. This is garbage. Get it out of here. Abs of this is less than or equal to 1. Yes, that abs. The one from Kotlin. Really? I thought there was one in Kotlin.math that we wanted that worked on ints. Am I wrong? And there's one that takes a Kotlin.int. What? Why can't I have that one? I mean, Javelin Math Abs takes doubles. I hate it, right? This abs takes ints and returns ints. Why doesn't it autocomplete this or import it for me or whatever? So, I believe this to be a sequence of bools that is whether the pixel being drawn is on or off. And then I just have to arrange this into a grid and turn the trues and falses. So map. I know you can combine two maps into another map. Into a single map. I'm not worried about efficiency here, clearly, since I'm working with boxed ints and boxed bools and all this garbage. Map on to well, actually, when can you just say it like is true one? Is this allowed? No, you have to say must have. Oh, add the other break. Add the others. This time it has no idea what's there, so I think I have to say when it remaining branches false. Okay, but I don't actually want one. I want hash, otherwise dot. Yeah. Then I want it chunked into 40s, please. What have I gotten as a result of this? A list of chars. Or a seek of list of chars. Oh my god. Dot map. Well, before I chunk it, I guess. Dot map of. No, I guess it's not before I chunk it. So I have to chunk it into 40s before I can turn it into a string. Map of. I have a list. Join. It dot join to string with no separators, please. I can't believe they had the separator be default comma space. What kind of psychopaths? Anyway. And now I want to join this with separator is new line, right? Let's see what happens. Where's main? Here it is. Oh, you have to return something, huh? Okay. Hell, let's inline this and make the whole. Oops, what button did I press? Whatever it was, whatever I said, undo that. I hit Alt N. Oh, I just opened the navigate menu and maybe hit enter. I don't know. But what I meant to do was this. There you go. We could make this, you know, an expression body. I don't think I'm going to. But I'll probably flirt with it a little bit longer. Hey, those are letters. My old Bridgelfulp. Great. So just how bad would this look if I made it expression body and threw an equal and a new line in there? First of all, note that if I say to reformat again, it'll put that back, which I don't like. But if I leave it alone, like, right? This seems okay. Oh, I like it. And we can inline the X's here as well. And make this expression body Although I kind of want, like, a new line there. Yeah, it doesn't put it back. Very good. Let's inline this one too. Put in my comfort new lines. Okay. Bridgelfulp. Bridgelfulp. Fulp. BRJLFULP. BRJLFULP. Yeah, that looks right. That's the right answer. Got it in one. So, I mean, not bad. This is kind of something that, or anyway, this, I guess, is something that we could probably reuse over multiple days. It's not super rare that Advent of Code asks you to render some pixels and look at it as a human being with eyes. Boy, it seems hard for blind people, right? Like, screen readers aren't going to handle this. How on earth are you going to... I don't know. Anyway, I think this is good. Let's just commit it. Part 2. All right, I guess we're out of here. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.